Hi, I'm here with Hugo Fan from Atlantis Computing, and we're going to talk their solution of hyperconverged software. Hugo, can you tell us more about it?
Yes, sure. So Atlantis USX is 100% software-defined solution. So we don't require any specialist hardware. We don't have a hardware appliance where our hyperconverged solution runs on. It's very, very simple to deploy. It's just an OVF that you deploy into vCenter. So today we support VMware vSphere as the underlying platform. And to create the hyperconverged data stores, we only require 3 hosts, so 3 ESX hosts. So you can use USX software on any hardware that you already have in your data center. For example, whether that be blade enclosures that you already have, you have investment in blades already, and you want to consume and use the same hardware, the same investment, you can do that with USX. If you already have rack servers in your in your data center, you could also use rack servers to create hyperconverged solution across rack servers also. Now, the other key benefit of USX is you don't necessarily just have to present and pull local storage. You can also pull shared storage from your current SAN arrays that you have today. So hyperconverged with local disks and also SAN storage as well. So you can create just a standard software-defined pool of performance and capacity together up into one hyperconverged environment with SAN storage as well.
So if I have a servers with local storage but no SSDs, I can just add some more SSDs in it and include it in the capacity and the acceleration layer.
Yes, you can. So what's special about USX is because it's 100% software, if you don't have hardware in your servers today, you can either use 100% pure memory to provide the performance acceleration and also the dedupe file system, which is, forms the core of USX. If you don't have much memory, you can install SSDs. Now the SSDs are They form and provide 2 things. They can either provide a performance acceleration layer, which is similar to vSAN, a read cache and write buffer, before persistent writes are written down to cold storage. Or you can build an all-flash hyperconverged environment where you use 100% SSDs for both performance and capacity as well. The reason why we can use all-flash environments where you have either local SSDs or PCIe-based SSDs, or even Diablo in-memory EX-flash DIMMs, you can use those to pull hyperconverged solutions by using all flash. Now, flash is very expensive,
but the prices are falling.
Yeah, the prices are falling. However, we don't actually use all the capacity of the flash because we dedupe at the volume layer. So when data is written to our volume, that deduplication occurs at inception time. So we don't actually need that, the full amount of capacity, for example, because we dedupe so well. So our file system is, 100% dedupe aware. We dedupe at inception time. So you can use you can use flash disks, but consume very little capacity on those disks.
Are there any limits or how many hosts I can have in my cluster with USX installed? No. Or is just the limits of vSphere?
So we don't, vSphere have certain limits on cluster size. However, in terms of pooling storage and capacity from underlying vSphere hosts based on the storage that's presented to those vSphere hosts, there's no limit. So with USX, you can add multiple vCenters to USX. Now, vCenters have many clusters, and many clusters have a lot of hosts, and hosts have a lot of storage, whether that be local storage or shared storage. So USX doesn't really care the size of the cluster or how many clusters you have or how many vCenters you have. All we care about is the type of storage, the amount of storage that you are presenting to vSphere, and then you present to USX to use as a capacity tier or as a performance acceleration tier. So your USX infrastructure can actually grow to very, very large scales. Yeah.
With this, I have another question, because I know you have a cool feature. You can teleport VMs, and this is exactly what can happen between 2 data centers.
Yes. So it doesn't have to be 2 data centers. It can be 1 to many or many to many. So, extending from the previous question where, what scale we grow to, the scale is vast because so USX manages many vCenters, and these vCenters could be in the same data center or in different data centers, geographically, separated over long distances. Now, how Teleport works is, as long as USX Manager, which is our management interface, can see and it has provisioned USX volumes in either data center 1 and data center 2. So that right now, let's use an example of just 2 volumes. Because USX understands deduplicated blocks, so the file system is 100% deduplicated. So let's say you had a VM running in data center 1 on data store 1, and you had also a number of other VMs running in data center 2 on a different volume. Call it data store 2. Now, if you look at the actual block composition of those data stores, let's say you had Windows 2012 VM that you want to migrate from one location to another. But on the other data store, on the destination data store, in the destination data center, you already have lots of Windows 2012 VMs running. Exactly. So if you look at the block composition between the 2 volumes, the key difference is only the unique amount of data or the application that you're running in data center 1 and the application that you're running in data center 2. So that's only a small difference based on whatever creates that VM, right? So, and another example is you have, your production environment in data center 1 and you have dev and test in data center 2, but your database is running the similar data set, right? You're just developing against something. So the key thing about Teleport is we know that the data is already in the destination. So what Teleport does is USX looks at the metadata construction of the 2 data stores, compares the hash between the 2, and let's say you want to move a VM from data center A to data center B. The destination volume actually builds the blocks from the blocks that it already has in the destination, and only sends a hash table to the source volume to tell it to only send unique blocks. So it only needs to send unique blocks, and the destination volume just builds up the VM blocks that it needs, and then once the unique blocks are sent, then that VM is then in the destination data store. So Teleport is a very, very efficient way to move huge amounts of data between, within a data center, between different volumes, or over long distances, yeah? So we're working, towards making that a better way to do storage vMotion inside a data center, and also long-distance storage vMotion as well, without sending those large blocks. Additionally, Teleport can be used to do backups, for example. Yeah. So instead of backing up a full VM and then doing deltas, which is what most backup products today, we actually don't do that initial full backup. We only back up unique blocks of data by sending that across. So that's a very long summary of what Teleport is, but it's a very, very new concept.
One last question.
Yeah.
What's the memory requirements of the controller VM actually?
Controller VM. So each controller VM that runs on each hypervisor host requires 4 gig of RAM. So by default, it's 4 gig of RAM. So generally, that is enough memory to manage the local storage, for example, that is presented to USX. So you can increase that memory if there's huge amounts of storage that you need to accelerate. Because what we use is something called vScaler to have enough memory to do the vScaler mechanism to make sure that we have enough hot blocks on fast storage, either RAM or SSDs, compared to cold blocks on cold storage.
And there is another place where you can put more RAM into your solution?
There is, sorry?
Another place where you can add more RAM?
Yeah.
We are talking the controller VM, and you thought about another place?
So if you don't have if you have a restriction in terms of RAM in your hypervisor, you can also use SSD as a performance acceleration tier. So that's where we you can use SSD or local flash, for example, PCIe flash devices, SSDs, or SanDisk or Diablo Ultra DIMMs as an example, to provide that performance acceleration tier, so read cache and write buffer. And that is actually a very good way to leverage flash, because you want to use RAM to provide memory for running VMs, not to provide a write buffer, for example. So SSDs is what basically I recommend. Yeah.
Thank you very much.
Okay, thank you, Vanadan. Cheers.